got that going. Okay, so let's see. Where are we? Where are we? Where are we? Where are we? Weekly activities folder. Boom. Here we go. Okay, so actually, you know what? Before I do that, let me scroll down here. Okay, so let me open up my Pronto here just so you guys can see it. And so, Jennifer, the third question, because again, the notes correlate directly to like to the homework problems, right? So let's see, where is my stats class? Oh man, I don't see it. Here we go. Okay, here we go. So this is, I know it says 6.2, but I fixed it. But this problem here, why do I have no volume? I don't hear anything.
It's due this Wednesday, right?
Yeah, it's due today, but why is there no volume here?
I might have not done it.
Okay, so I'm going to check something real quick. I'm going to check it on my iPad. Maybe it's something's popping up here. Let me see. That. There's volume, right?
Yeah.
I think so. Okay, are you playing it on your phone? Okay, okay. Yeah, I don't know why it's not coming up with volume here, but so this is number 3 from the homework. So again, your problem might be slightly different from mine, right? And this one of our classmates asked me to do this one, but I do walk you all through the process. And again, I just don't know why I'm not getting. You know what? So now we have. Hello. There we go. Turn on the volume, dude, right? Okay, but anywho, so I do walk you through the process, right? On showing you how to do this one, because what ends up happening with the third problem is that number one, they're giving me a specific interval, right? They're giving me, we want to do it over the interval from -8 to -8 to 2, okay? So what ends up happening is we find the points where they intersect, right? So we find the points where they intersect, and let me actually do it this way just so you guys can see what I'm referring to. Okay. So I'm just going to kind of do like a very rough graph here. Yeah, let me go back and look at what the functions were because I don't remember off the top of my head. 10 minus x squared and -3x minus 30. Okay. So 10 minus x squared looks something like this. Okay. -3x minus 30 looks something like that, right? Okay, so we find the points where they intersect, right? And I do that deal for you guys. And they intersect here and they intersect here. But we're looking for over the interval between -8 and 2. So now I'm wanting to find the area bounded by those graphs. So look what I'm doing. I'm finding this area and I'm finding, come on, Ben. And I'm finding this area. So if you notice, the line is the top function here, right? Because that line is the one that's above the parabola. You see what I mean? But then from here to here, the parabola is now the function that's on top. Okay. So when you're going to do number 3, y'all, my recommendation is watch the video that I sent you guys on Pronto, and it walks you through the process on how to set yours up. Does that make sense? So if you haven't yet done number 3, what I would recommend doing is watching that video that I sent you guys because I break it down completely for you and I do it in pieces. And I show you without actually having to draw the picture, how do I know which is the top function? And the way I did that, y'all, is I said, look, since we're going to do this at -8, let me plug in -8 into this function and let me plug in -8 into that function. And whichever value is bigger, that has to be the top function. Does that make sense? And then let me plug it in over here, and then whichever value is bigger, then that has to be the top function, right? So that you know how to break up your interval, because it's going to be 2 intervals that you're going to have to do. Like you're going to have to find the area here, and then that's going to be 1 interval, and then you're going to have to find the area there. Okay. and then we add them together. That's right. Okay, so excellent questions. Good, good, good. Glad you definitely asked that. Okay, y'all, so let me go ahead and get my notes for what we are doing today. And I believe what we're doing is we are finishing up 6.2, which we had a couple of problems that we still needed to do. I'm just trying to see if I can find where I wrote, where I have my notes for 6.2. Because as you guys know, I don't label anything here, right? I don't know, I've always been like that. Here we go. I'm pretty sure this is it. I'm pretty sure, but maybe not. Let's see. Areas between the curves, which we did. And so look, just to give you a heads up, that's like number 3, kind of similar. Okay. Okay, here we go. So we left off on 6.2. I believe this was probably the last question that we had done. I think there was still 2 more to do. Yes, we got to do. Excuse me. We got to do these 2 problems here. Okay. So let's see if we can't figure this out, y'all. Let me get some water real quick. And actually, you know what? Before I do that, I'm going to come back over here real quick to my, let's see. Okay, so week 14, y'all, just to give you a heads up, that's the week that we're in. So when you click the notes here, because we're going to do, this is kind of giving you a heads up of what we're going to do, right? So on Monday, obviously, we didn't have class. I was me giving you the day to take the test. So today, y'all, we're going to finish up 6.2, and then we're going to go over 6.3, okay? And so 6.2 and 6.3, y'all, are due next Wednesday at the end of the day, okay? Bless you. So the homework for 6.3 is here, y'all. Again, we'll get that started in a little bit. But the other thing I want to let y'all know, I went ahead and I've already created our final and our review. So actually, let me talk to you about that for a minute before we go into chapter 6 or finishing up 6.2. So here's the info on the final exam. Let's see. So what I have here. So okay, y'all. What I did here is I have the formula sheet for test 1. I have the formula sheet for test 2. And what I have is I made a formula sheet for chapter 6. So I have those 3 formula sheets right here. So, y'all, when we've been doing our reviews, the reviews normally had 40 questions, but the review for the final this time only has 30, okay? And it's due by 8 o'clock Thursday, May 12th. Wednesday, May 4th, y'all, which is a week from today, and Monday, May 9th, which is not this coming Monday, but the Monday after that. What we're going to do is we're going to review for the final. We're actually going to have 2 days to review for the final, okay? So on Monday, May 9th, the final exam is going to open up as soon as class is over, okay? I need to change this right here. It's supposed to say the final, but it should say the final exam has 20 questions chosen directly from the review. So still 20 questions, y'all. But look, now I'm picking 20 out of how many? Out of 30. You see what I'm saying? Now, guys, how did I make the review? The way I made the review is I picked questions directly from test 1, directly from test 2, and from the homeworks that we have in chapter 6. Okay? So the review, guys, all the questions you're going to see in the review, they came directly from test 1. They came directly from test 2, and a little bit of stuff from chapter 6. So what I want you to think about, before I go on, what I want you to think about for a minute is if there was a question, say, on the review for test 1, but it wasn't on the test itself, will it be on the final? No, because I picked the questions directly from the test. Does that make sense? Okay. So again, I'll fix this right here, y'all, because it should say the final exam. But 20 questions picked from those 30, right? You can use the formula sheets. You can use the calculators. Still get 2 shots at the test. If you're happy with the grade, you don't got to try it again, okay? So again, I have those formula sheets here. So y'all, next Wednesday and the following Monday, all we're going to do is review. Today, we're going to finish up 6.2, which I still have 2 more problems. We're going to go to 6.3, which only has 3 questions, okay? Next Monday, you guys, we're going to do 6.4, also 3 questions, right? So what I'm really trying to convey is we are, like at the end of the journey, you know what I mean? The homework that you're going to have from 6.2, there's only 2 more questions I got to cover. What I'm going to do after that, 6.3, there's only 3 homework questions. And then next Monday, 6.4, only 3 homework questions, okay? So it's kind of like we've already done the hardest part, okay? Now, guys, again, don't ignore the review, right? And don't ignore the final because it's still part of the class, right? But what I'm saying is in terms of us learning a whole lot of new material, we're kind of at the end of that part already, okay? So again, I'll fix this part right here. Actually, you know what? Let me fix that real quick because I'm going to just say the final exam because that's what it is. There we go. Okay. So I feel better about that. All right. And then again, y'all, and I'll check to see if this is already open. I want to say it is, but I don't know for sure. Yes, it is. So the review for the final, guys, is already open, okay? The final exam, obviously, is not, right? It's not available yet, but it'll open up on Monday, May 9th. But the review for the final is already open. The reason why I opened it up, so that you can do a little bit at a time, right? Nobody's going to sit down and say, okay, let me crack my knuckles and let me start these 30 questions and get them all done in one session, right? It's too much to do. But try working it out a little bit, you know, over the next few days so that we have time to review that stuff. Okie dokie. So, okay, now let's get back to what we were doing, which is finding volume, okay? So the problem that I have here says, let's find the volume of a solid obtained by rotating the region in the first quadrant bounded by the curves x equals 0, y equals 1, x equals y to the third about the line y equals 1. Okay, so y'all, this is the first thing I'm going to do. I'm going to draw a picture, okay? Whoa. I'm going to draw a picture here. I'm just going to put my XY axis, okay, X and Y, okay? Now, let's look at the bounds that we're doing. It says in the first quadrant, okay, bounded by x equals 0. So x equals 0, you all, is this vertical line, which is the y-axis, okay? Bounded by the line y equals 1. So I'm going to say this right here is y equals 1, okay? Now, what I need to do is I need to figure out how would I graph x equals y to the third, okay? So y'all, one thing we can do, we can solve this equation for the letter y by taking the cubic root on both sides, okay? The reason I want to take the cubic root is because it's a y to the third, right? So the cubic root of y to the third, y'all, is just going to leave me with a y. And I don't know if you remember, anybody remember how would I write the power so that it's a power as opposed to a root if it's the cubic root of x? Yes, very good, x to the 1/3. Okay, so now what I'm going to do is I'm going to go ahead and draw a picture of that. Y'all, I don't know if you remember, I'm just going to kind of do this on the side real quick. I don't know if you remember what the square root function looks like. The square root function kind of looks something like that, right? The square root, when you're graphing, say y equals the square root of x, it looks something like that. The cubic root looks very similar. The only thing that happens is that it kind of shoots up a little faster, okay? It does something like that, okay? So right here, let's see if I can draw a little arrow to it. This is still 6.2. This is the fourth problem in 6.2 because we hadn't yet finished it. Okay. So now, this is what we're looking for. We're trying to find the volume of the solid obtained by rotating the region in the first quadrant. So I want you to think about what we're rotating. We're rotating this piece right here. Okay. And guys, look at how we're going to rotate it. We're going to rotate it about the line y equals 1. So what I want you to think about is, think about this line here. Think about it like a wire, and you were to do this. You see what I'm saying? You're rotating it like that, right? So what's going to happen is we're going to end up with something that looks like this, okay? And now what I have here, y'all, is we have basically like a cone, right? Like that. We have a cone here. So let's see. What we're going to do, y'all, is we are going to, let's see if I can do this in green. We're going to make little discs, okay, like a little circle like that, okay? And we're going to find the volume of each of those little circles. So the way we find the volume of a cylinder, right? The volume of a cylinder is pi r squared times h. Okay? So my volume here is going to be pi. Now I need to find my radius. So I'm trying to see if I can do this in a better color. Let me go like that. Yeah, that'll work. Okay. So my radius, y'all, is the distance from there to there, right? Or the distance from there to there. So if I want to find is the distance from this function, which is x to the 1/3 minus 1, right? Because I'm measuring the distance from here to here. And I know that this value right here is the cubic root of x, right? And the distance between there would be the cubic root of x minus 1. So right here, y'all, I'm going to write the cubic root of x, or x to the 1/3 minus 1. Now, remember, the thickness, y'all, the thickness of that is just that real small sliver dx, right? Okay, so here's my formula for my volume. Volume equals pi r squared times h. Yes, ma'am. To the second power, right? So when I'm finding the volume of a cylinder like this, right, and h, the volume is always pi r squared h, right? Except our cylinders are looking kind of like this, but they're really, really narrow. You know what I mean? They're so it's kind of tilted on the side, right? But here's my radius, and my height is that little change in dx. Right?
And dx is
So dx is the thickness, and it's just how much did I move from there to there. It's that infinitesimal thickness, right? So kind of like, remember we talked about it the other day when you put your penny in the little machine at the museum and it flattens it out. Remember we were talking about that? It's the same kind of idea here. Okay, so y'all, I got a couple of steps that I need to do. The first thing I need to do is I need to square this guy here. So I'm just going to zoom up a little bit and let me figure out what is x to the 1/3 minus 1 squared. Okay, so we're going to square this thing. So remember, FOIL method here, y'all. We're going to go one piece at a time. X to the 1/3 times another x to the 1/3. Remember, with our exponents, y'all, we're just adding the exponents together. So what's 1/3 plus another 1/3? There you go. Okay. X to the 1/3 times a -1 is a -1 x to the 1/3. Right. -1 times an x to the 1/3 is another -1 x to the 1/3. And a -1 times another -1 gives me a positive one, right? Okay, everybody agree that we can combine those two terms in the middle? Isn't -1 x to the 1/3 and another -1 x to the 1/3 a -2 x to the 1/3 plus 1? Okay, so now, y'all, now we can start doing the calculus part. So let's do the calculus part. We're going to integrate, okay? We've already found this value squared. So I'm going to leave my pi on the outside. We already squared this guy, and we came up with x to the 2/3 minus 2x to the 1/3 plus 1 with a dx. What we need to do, y'all, we need to find our limits of integration. So we need to figure out where are we integrating from. Now, we're doing this on the x-axis, right? So I want you to think about, look where we're starting off with. We're starting off right here. So what's my lower limit? If I'm starting off right here on the x-axis, 0, right? Okay, we're going to go to this point right here. Okay, so we're going to go to that point right there. If I want to find what is the x value right here, look at the y value of this line. The y value is what? 1. So hold on. Let's go really slow. So the y value is 1. So y equals 1, right? And we also have this equation here, which was y equals x to the 1/3. So what I'm going to do is I'm going to set these two equations equal to each other, y'all. x to the 1/3 is equal to 1. Okay. I'm going to go ahead and cube both sides so that those will cancel. 1 to the 3rd power is still what? Still 1. Okay. So there are my limits of integration. Okay. Does that make sense on how I was able to find that? I'm sorry? But we don't know. Remember, we still got to find, we have to do the integration, right? We got to find those antiderivatives. Okay, so look, we're going to go really slow here, y'all. I'm going to leave my pi as it is. Okay. Now we're going to start integrating. Okay. I want you to think about x to the power 2/3. Remember how we find the antiderivative? We add 1 to the exponent. Okay. Now, my exponent right now is 2/3, right? So if I'm going to add 1 to that, how would I write 1 as a fraction with a denominator of 3? 3/3, right? Okay, so look, we're going to get x to the power 5/3, right? Now, don't we need to divide by that same number? So the reciprocal, Jennifer, do you agree 3/5? Okay. Minus, I'm going to leave my 2 because the 2 is still part of it. Now, y'all agree that when we add 1, we're going to be adding 3/3, right? So what's x to the 1/3 plus 3/3? X to the 4/3. And then we still got to do our reciprocal, right? What's my reciprocal of 4/3? 3/4. So look, I'm going to put a 3/4. Now, guys, I'm still multiplying by the 2. We're going to come back and fix that business in a little bit. Plus, what is the antiderivative of 1? X, right? Okay, and we are, again, evaluating this from 0 to 1. So now, look, y'all, I'm going to have a pi here, okay? I'm going to leave this as a 3/5 x to the 5/3. Now, do you guys agree that we can reduce the 2 and the 4 there? So isn't that going to be, what, minus 3/2? Right? Because 2 goes into 2 once and 2 goes into 4 2 times. Okay, x to the what power again? 4/3. Okay, plus x. And again, we're evaluating this from 0 to 1. Okay. All right, so remember, y'all, what are we going to do now? We're going to come back to this expression, and everywhere we have the letter x, we're going to plug in what number first? 1. Okay, so let me ask you a question. What is 1 to any power? 1. So aren't I really just going to be left here with y'all a 3/5? Same thing over here. 1 to any power is still going to be 1 minus 3/2, right? Plus, when I'm plugging in x, isn't that just going to be 1? Okay. Minus, because this is a definite integral, we got to subtract. But what number are we going to plug in the second time? What happens when we plug in 0? All that's going to wipe out, right? Because everywhere we have an x, we're going to have a 0. So we're just going to subtract 0. We're not really going to change anything. Now, at this point, y'all, what I would do if I were you, I would grab my calculator right here. And let me clear that out. I would do this. 3/5 minus 3/2 plus 1. Okay. 0.1 times what number? Times pi. And I'm coming up with 0.31459, right? There's my answer. Or pi/10. And you're done, right? So again, y'all, my open math is pretty forgiving. So 0.31459, whatever. Where's my calculator? 314,159. So there we go. There's my answer. So, guys, I want you to notice something. What we're doing in all these problems, and again, we did some of this last week, but I know it was a few days ago. Look at the formula that I'm using. I'm using the formula for finding the volume of a cylinder, right? And when I'm finding the volume of a cylinder, I'm always using that pi r squared h, right? Pi r squared h right here, okay? And notice in these problems here, y'all, we were rotating about the x-axis, right? In the problem we did before, we were rotating this about the x-axis. And the first problem we did, we were rotating this about the x-axis. The only difference in this one, we were now rotating about the line y equals 1, but that's still a horizontal line, isn't it? We just had to shift it up a little bit. Does that make sense? But that's in essence, that's what we were doing, okay? So let me jump to the next problem, and you guys tell me if this makes sense. Now, what we have here, y'all, is something called the washer method, and I'm going to explain the idea behind the washer method to y'all. So the washer method says, suppose f and g are continuous non-negative functions so that f of x is bigger than g of x over the interval from a to b. Let capital R denote the region bounded above by the graph of f of x and below the graph of g of x. On the left of the line x equals a, and on the right of the line x equals b. Let's see, the volume of the solid of revolution formed by revolving R around the x-axis is given by, and they give me a formula here. Okay, so let's see if we can figure out how to do this problem. So it says, find the volume of a solid obtained by rotating the region bounded by the curves about the specified axis. Okay, so the first one is y equals x to the 8th. So again, the first thing I'm going to do, y'all, I'm going to draw my picture. Okay. So here's my picture. Okay, you've got my x-axis, and I got my y-axis, okay? So y equals x to the 8th. So guys, y'all know what a parabola looks like, right? It looks like a cup like this. The only difference between y equals, say, x squared, and when the power of x, and it's an even power, and it starts getting higher and higher and higher, what happens is, say that's a negative one, that's a positive one, and I'm going to say that's a positive one on here. The graph does something like this. It's really flat, and then all of a sudden it kind of shoots up, okay? So whereas a parabola is a little bit more gentle of a curve, when I have an even power, and that power is higher, like 8 or 6 or 10, stuff like that, it just really flattens out, okay? So here's my y equals x to the 8th, okay? Now, we also want to draw the line y equals 1. So here's the line y equals 1, okay? And let's see. We're gonna rotate this about y equals 3. Okay, so let's take a look and let me see where I can find y equals 3. So say that's y equals 2, y equals 3 is right here. So, y'all, this line right here is going to be the line that we're going to spin it across. Okay. So what I want you to think about, the graph is going to do, so I can zoom down a little bit. That's 3. The graph is going to do, I can't draw very well today, so I'm going to try something like this. I'm rotating it about that line, okay? So I want you to think about what's happening here. We're spinning this guy. So we're getting this kind of a spinning action, right? But we're only finding the volume that's being rotated by that part. So what's happening with this stuff here in the middle? We're not using that part. We're just doing, I'm trying to see if I can draw a better picture here for you guys. See if I can do this a little bit better. You know what this is going to kind of look like? Think about it like a donut. We're kind of having like a donut, and we're trying to find the volume of the donut. And what do you have in the middle of the donut? Yeah, the donut hole, right? That's the part that we're not eating. So we're kind of doing that action here. Does that make sense? Because we're rotating it like this, right? So yeah, so what we got to do here, y'all, we're going to find the volume. We're going to do it in pieces. So the reason why we call this the disk method is we're going to be basically be subtracting a couple of different pieces. So since I'm rotating it about this line y equals 3 right here, I want to find the radius of, say, this disk, okay? Now think about the radius of that disk right there. The way I would find the radius is I would take whatever value I have right here. Well, that value, y'all, is x to the eighth, right? Because that's the definition of my function, right? It's y equals x to the eighth. Wherever I go, my height is going to be x to the eighth. I'm trying to find the distance between there and there. Now, the graph of that line is y equals 3, okay? So the way I'm going to find my big radius, it's going to be x to the eighth minus 3, okay? This circle right here, this one, the green one, yeah. Well, because what well, yeah, actually, you know what? That's not my circle. You're right. My circle should look something. No, you're right. My circle should look something like that. You're right. My bad. But this is still here, my radius, right? Sorry, you're right. This here's my radius. That's right. So that's my big circle right there. And my radius is the distance between those 2 points. You're correct.
So, the limit would be about 5.
We're gonna figure that part out in a second, right?
Like the center point is the
Uh-huh.
bottom,
Yeah. We're gonna go through all that kind of stuff in a second. So look, y'all, the way that's gonna be my outside radius. Now look what I have to do. I have to find that radius squared. So let's go ahead and see if we can square that part. So my r squared is going to be x to the eighth minus 3 times another x to the eighth minus 3. Okay. So now let's go through it. Let's do it in pieces. So let's see. We're going to FOIL this thing out. X to the eighth times x to the eighth. Remember, we're adding the exponents, right? X to what power? 16. Good. X to the eighth times a negative 3 is a negative 3x to the eighth. A negative 3 times x to the eighth is another negative 3x to the eighth. And then what about negative 3 times negative 3? 9. Very good. Okay, so guys, look, now we're going to have an x to the 16th. When we combine these two in the middle, a minus 3x to the 8th and another minus 3x to the 8th. Anybody know? Negative 6. Very good. X to the 8th plus 9. Okay. Now, we do have that inner circle, right? We have this circle right here. So guys, remember, we're trying to find the radius of that circle. So look, what's the radius of that circle? If this here is the line y equals 1, and this here is very good. So the radius of that circle, and y'all, for the radius for the smaller circles, just to kind of keep things easy, they use a little letter r, because it's the inner circle. It's the smaller circle, okay? And what we're going to do is, if we know that the little letter r is 2, what would r squared look like? 4. Okay. All right, y'all. Now, all I'm going to do is slap on that formula right there. We're going to integrate. I'm going to leave my pi on the outside. Okay. Now, the bigger radius squared was this guy right here. So I'm going to write it in parentheses, x to the 16th minus 6x to the 8th plus 9. We're going to subtract off the smaller radius that we squared, which was 4 dx. Okay. Now, y'all, let me ask you a question. What do you think my limits of integration are? Just by looking at the picture. And my limits of integration, y'all, are on the x-axis. Very good. From -1 to 1, because we're doing all of this here, right? All of that area. Very good. -1 to 1. Okay. So let's keep working here. So look, from -1 to 1 of x to the 16th minus 6x to the 8th. Guys, what's a plus 9 and a minus 4? 5. dx. Okay. Oops, don't forget my pi out here in front. Okay, let's start finding some antiderivatives. So I'm going to leave my pi alone. Okay, anybody know what is the antiderivative of x to the 16th? Very good. X to the 17th over 17. Okay. Minus, I have a 6, so I don't want to forget it. What's the antiderivative of x to the 8th? Very good. X to the 9th over 9. Okay. Plus, what is the antiderivative of 5? 5x. Good. Okay. And again, y'all, we're going to evaluate this from 1 to negative 1, right? Or from negative 1 to 1. Okay. Now, if I was sitting where you're sitting, I don't feel like plugging in a whole bunch of numbers like this. And my open math, again, guys, for these problems here, these are, we're getting like approximations, right? So this is what I would do if I were you. So I would go to my y equals. Oh yeah, we can do that too. That's a good point. Let's do that. 6 over 9, we can reduce it to what? 2/3? There we go. Good, good, good. So guys, if I was sitting where you're sitting, this is what I would do. I would type in 1 over 17, x to what power? 17. Okay. Minus 2/3 x to the 9, thank you, plus 5x, close it off. Oh, I don't need it, thank you. Enter, there we go. Okay, now what I'm going to do, y'all, I'm going to go y bars. Remember, we're going to plug in a 1, and then we're going to plug in a negative 1, and we're going to subtract the 2, right? So right here, I'm going to do this at 1, minus, I'm going to do this again at negative 1. Okay. And I'm coming up with that number right there, and I still need to multiply it by what? By pi. And so my answer that I'm coming up with is 27.5967. Yes, give me 1 second. So 27.5967. There's my ball. Tell me, Don.
Can we kind of follow the feedback because
Oh.
So why did you kind of like the two, when you find it starts with negative 1 to 1?
Because that's my limits of integration, right? When I drew my picture, right? When I drew y equals x to the 8th, I have to draw the whole graph, right? Which the whole graph would look something like this, right? But since I'm doing it where it intersects with that line y equals 1, don't they intersect right here at those points? You see what I'm saying? Because we're looking for the points where they're going to intersect with the line y equals 1, right? So this is the region that I'm looking at, and that's the region I'm trying to rotate. And then I'm rotating it this way, right? So I'm kind of getting that donut type of action, right? It's kind of looking like a donut because we have this middle piece here that we're not using. And in essence, guys, all we're really doing is we're basically doing two problems. We're finding the area the first time. We're finding the area of like this little piece right here. Or not the area, but the volume. We're finding the volume of this piece right here, and then we're just subtracting that part off, right? Uh-huh. Okay, very good. Right here, so I want you to notice in my formula, we're going to square both of them, right? We're going to square both of them. And so that's why we said, look, once we know what the big R is, let's find the R squared. And then once we know what the little r is, let's find that R squared. Because the formula is going to have f of x squared minus g of x squared. like the outer radius minus the inner radius. I'm sorry, say that again? This is 6.2, finding the volume of, in 6.2 it's volume, and 6.2 is really doing it either by the washer method or the disk method. So all the problems we did before with the disk method, this is the only one that y'all have to do by the washer method. Okay, so guys, let me go ahead and pull up the notes for 6.3, and we'll do that one. We just got 3 problems here out of 6.3. So guys, one thing I want to emphasize here in doing these problems, let me see. Okay. So in 6.2, we were basically doing the washer method or the disk method. And guys, in all of those problems, the problems we just got finished doing, let's go back to it, here we go. I want you to notice that we were rotating everything either about the x-axis or some kind of a horizontal line, right? Whether it was y equals 1 or y equals 3, but they were getting rotated this way. Does that make sense? Right, like all the problems we just did right now, right, and the ones we had done last week, everything was being rotated about the horizontal line, whether that horizontal line was the x-axis or whether there was some other line like y equals 1 or y equals 3. In 6.3, guys, we're doing something called volume revolutions. We're doing something called the shell method, and we're actually going to be rotating here, y'all, about the y-axis. So we're going to be rotating things this way. Okay, it's going to be rotated like this. Okay, so it says the method of cylindrical shells. It says we're working with solid of revolution. We're going to define a region R above the graph and below the x-axis, and on the left and the right, the lines x equals a and b. Okay. So let's see, guys. I want you to notice where the a and b is coming from. The a and the b is coming from here. Those are my limits of integration. But again, we are rotating this thing here about the y-axis. Okay. So let me jump to where the formula is, so I can kind of show you the process and how we're going to be doing. The easiest way for me to do it, y'all, is actually just showing you a particular problem. But I'm gonna demonstrate what it is I'm trying to do. So I have a formula here. Volume by shells. It says let R be an area bounded by the graph y equals f of x, the x-axis, and the lines x equals a and b. If R is rotated about the y-axis, the volume of a solid of revolution is given by, and it says 2 pi, the volume is equal to 2 pi times the integral from a to b of x times f of x dx. I'm going to explain the process, y'all, okay? I'm going to explain it by doing this problem here. So I want you to notice what we have. It says find the volume of the solid obtained by the rotating the region bounded by y equals x squared, y equals 0, and x equals 2 about the y-axis. Okay, so the first thing I'm going to do, y'all, I'm going to draw a picture. So here's my x-axis, here's my y-axis. Okay, I want to draw the graph y equals x squared. So y equals x squared, here's 1, and here's 1, here's 2. Okay. So that's the line, that's the graph of y equals x squared. I'm only doing half of it right now because we're going to rotate it about the y-axis anyway, right? So there's my y equals x squared. We're going to bound it by y equals 0. Y equals 0 is this line right here. And we're going to bound it by x equals 2, which is this line right here. Okay. And y'all, we are going to rotate it about the y-axis. So here's my y-axis. Okay. Think about, y'all, I want you to think about it this way. Think of this as kind of like a piece of wire or something, right? And I put a little clavo, a little nail right there. And I'm going to be spinning the whole thing this way. So do you guys agree that what would end up happening is I'd have something that looks like this, right? And this thing is now starting to rotate that way? Okay. So we're getting something that looks like that, right? But again, we're only looking at so it's kind of hard to see, right? But you kind of get the idea that there's like a hollow part in the middle, right? Like we've kind of like if you were playing in the sand and you kind of made like a little thing like this with your finger, or like when you're ever in the pool, you ever see when the water starts to do that number? When you're a kid, when you ever go to the pool, would you ever go like this in the water? Right? To make like a little whirlpool, you know what I'm talking about? That's kind of the action that we're getting here, right? Okay, now y'all, we're going to use this idea of these things called shells, okay? What I mean by a shell is I'm going to draw a really, really narrow rectangle, super narrow, okay? And what I want to do is I want to rotate that little rectangle all the way across. Okay? And so what I end up with, it looks almost like a ring. I don't have a wedding ring, I'm not married or anything like that, but it's almost like a ring, right? So it's really, really thin, like a little band, right? But that's basically what I'm getting, kind of getting like a little ring here, okay? Now, what I want to think about doing, y'all, is if I were to take that little ring that kind of looks like this, right, and it's super, super narrow, I want to think about if I were to take that ring and kind of cut a little line here, right? Just kind of draw a line where I cut it in half. And I were to extend that, I would have folded let it roll out for lack of a better term. I would now end up with something that looks like this. Okay, you see what I'm saying? Like if I had a ring and I cut my ring and then I kind of spread it out like that. Okay. I want you to think about the value right here. The height of that ring, y'all, is whatever my value f of x is, right? Because that's my y value. That's the distance from there to there. Okay. Now, I want you to think about these circles right here that we made, right? Would you guys agree with me that the radius from here to here would just be the value of x? Because it's the distance from the middle to wherever I'm going on the outside. You know what I'm saying? So like if I were to move this way, if I were to move, the distance there would be 1. If I were to move over here, the distance there would be 2, right? So the value of that radius, y'all, is x, okay? Now, if the value of that radius is x, and what I did here, y'all, is I cut that ring and I kind of spread it out, right? I want to know how long is it across, like what's the circumference of that circle? Does anybody remember the formula for the circumference of a circle? Anybody remember that formula? 2 pi r, right? So it's going to be 2, yeah, or pi times the diameter, but it's going to be 2 pi x because my radius, y'all, happens to be x, okay? So I want to show you something. The height here, y'all, is my f of x, okay? The distance from here to here is my 2 pi x, okay? Now, the thickness of that little rectangle is my dx, okay? I want you to think about what I have here. I have like a little thin bar, right? A little thin bar. The way we find the volume of a box is the length times the width times the height, okay? So I want you to think about the length of that box. The length of that box, though, weren't we calling that 2 pi x? Okay, the height of the box, weren't we calling that f of x? That was the height, that was the distance from there to there? Okay, times the thickness, right? The thickness, y'all, is that little dx there. Okay. I want to point something out here, y'all. Look at this formula here, and I'm going to scroll back over here. Look at my formula right here. Look, here's my 2 pi, here's my x, there's my f of x, there's my dx, right? Okay, so look, we're going to apply that formula to our problem here. Okay, so I'm going to leave the 2 pi outside. Okay, we're going to integrate x, so I'm going to leave the x here, and then the f of x. Guys, look at what my f of x is equal to. Wasn't my f of x in this case what? X squared dx, okay? Now, yo, since we're rotating this about the y-axis this time, our limits of integration are from here to here, because this is the part that we're rotating. So we're going to integrate from 0 to what value? To 2. Tell me.
On the bottom is 2 pi x f of x dx.
Yes, sir. Because it's the length times the width times the height. Okay. So look, we're going to do the same thing here. We're going to go 2 pi, okay, from 0 to 2. Y'all, x times x squared, everybody agree, is x to the third? Dx? Okay. So here's my 2 pi. Okay, guys, we're going to start finding some antiderivatives. Anybody know what's the antiderivative of x to the third? X to the fourth divided by 4. And again, y'all, we're going to evaluate this from 0 to 2. Okay. So remember, the first thing we're going to do, we're going to plug in a 2, right? Okay. So that's going to be 2 to the fourth over 4 minus, we're going to plug in a 0, 0 to the fourth over 4. Okay. All right. So the volume is equal to, okay, 2 pi. 2 to the fourth. 2 to the fourth, y'all, actually gives me 16 over 4. 0 to the fourth divided by 4 is just going to be 0, so that piece is going to go away. Okay. 16 divided by 4 is 4. My answer here, y'all, is just 8 pi. Again, you can type in 8 pi, or you can find the decimal approximation, and my open math will be good with either one, right? So if you want to go 8 pi and write 25.13274, you can do that as well, okay? It's not going to be 50 easy. Are we doing okay here? Am I losing you guys? Oh, I'm fast? Okay. I will definitely go much slower on the second part. Okay, so look, let's try the second problem. I promise I will go much slower on this one to make sure that we're good here. Okay, so let's take a look at the second problem. It says use cylindrical shells. Define the volume of a solid obtained by rotating the region bounded by y equals x squared, y equals 0, and x equals 1 about the x-axis. Okay, so the first thing I'm going to do here, y'all, I'm going to draw a picture. Okay. Okay, so look what we're looking for. Y equals x squared. So guys, y'all agree that y equals x squared does something like this? Right? And again, I'm only doing half the graph, but I want to explain why I'm only drawing half the picture. Because it's going to be, look, I can actually draw the whole picture. I can do this action if I want to, right? Now, the other part says y equals 0. Well, here's y equals 0. Okay? And the third one says x equals 1. So x equals 1 is right there. Where do those parts intersect? They intersect right there. Does that make sense? That's the area that I'm looking at. I'm looking at rotate. Before I go on, are we good on how I got my picture? John, am I good? We're good? Okay. Now look, y'all. We're going to rotate this about the what? What did it say? About the y-axis. Okay, so look. Here's my y-axis. So that region is going to be that same region there. Okay? Guys, look, my picture isn't perfect, but it's okay. I get an idea of what's happening. Okay? It's just like the problem we did before. Again, like think about when you were a kid. I don't know about y'all, but even as an adult, if I get in a swimming pool, I'm doing this just to make that little whirlpool. You know what I mean? That's kind of what we're having, right? We're having that little whirlpool, and we're not finding the volume inside. We're finding the volume kind of like outside of that whirlpool. You know what I mean? Like the outside part of the cone. Okay, so the way we're going to do this, y'all, we're going to make the shell method. Okay, this is what the shell method says. The shell method says, let's make a little rectangle. Okay, and what we're going to do is we're going to rotate that rectangle across. So we're going to end up with something like that. Now, let's think about what we made here. We made like a little ring is basically what we made. Okay. Okay, so what I did is I said, the way I'm going to make my ring, John, I'm going to make a really thin rectangle. Okay. And what I'm doing now, John, look at me. I'm doing this with it. Okay. So think about my finger here, John. Me doing this kind of action, right? Yeah. So it's all I did is make a little vertical line, little vertical rectangle, and I'm just doing this now, right? So I want you to think about that for a minute, y'all. And I'm gonna kind of I don't know if anybody's watching at home along with us. Let's see, can I get here at home? Yes, we got Noel here at home. So Noel, I don't know if you can see me. I don't know if you can see me or not, but I'm gonna stop sharing the screen and I'm gonna share the camera. Like this. Here we go. Okay, so this is what I'm doing. I'm doing this with my fingers. Okay. So guys, if I'm doing this with my fingers or doing this, say, with a pen, and I'm rotating it this way, do you agree that I'm doing this in a circular motion? Does that make sense so far? We got a circular motion here, right? Okay. So let's come back to my screen. Put that there. Get rid of that. Boom. Okay. So we made that little circle there. Okay. The first thing I'm going to do, y'all, I'm going to find the height of that circle. The height of that circle is whatever that vertical distance is. That vertical distance, y'all, is my height, whatever my function f of x is. Okay. In this case, y'all, my function f of x is x squared. Everybody agree? Okay. Now, the next thing I'm going to do, I'm going to find the radius of that circle. The radius of that circle, y'all, it's just the distance from here to here. Well, that's just whatever x value we end up picking. You know what I mean? It's just going to be whatever my x value is. because I'm going from x equals 0 out to a particular value of x. Okay, the next thing I want to do, y'all, I want you to think about the circumference of that circle. The circumference of the circle is 2 pi r. But we just said that my radius happens to be x. Okay? Y'all, if I could come over here and draw and cut that little ring, right, that I'm making, right? Cut that, just a little line like that, and spread that whole thing out, this is what it would look like. Okay? For the distance from here to here is that 2 pi x, okay? Because we cut a line right here and we spread it out. You all ever seen that gum that comes in a little roll, right? You know what I'm talking about? That gum comes in a roll. Think about if you had a piece of that gum just perfectly connected, and then you were to cut that gum in half, and then you were to stretch it out, right? So
Okay, I do.
you see what I'm saying now? So the circumference of that circle is now the length of my rectangle, right? So that's why I'm saying the length is 2 pi x. Now the height of that rectangle, y'all, is x. And the thickness, it was super, super, super thin. That thickness, y'all, is my dx, right? So how do I find the volume of a box? It's always the length times the width times the height. So the length is 2 pi x. The width of the box is our x squared, and the height or the thickness of the box is my dx. Does that make sense? It's a three-dimensional box. It's just that one of the dimensions, John, is really thin, just like that gum. I wish I would have thought about that earlier, and I would have brought a roll of that gum and just, or even if you buy a stick of gum, juicy fruit, and you know what I mean? Take a stick of gum and do that with it. Yeah, or tape, whatever, right? There's your, that's what the shell looks like, right? Okay, so take a look, y'all. We're going to go ahead and start integrating now. Look at my limits. My limits, y'all, always go from the origin to whatever that point is on the outside, and that number was a 1. So my integral is going to go from 0 to 1. I'm going to leave my 2 pi outdoors, okay? And we're going to multiply here. What is my x and my x squared going to give me? X cubed, very good, with my dx, okay? All right, guys, we're going to integrate just like we did before. We're going to find our antiderivatives, okay? Anybody know the antiderivative of x to the third? X to the fourth over 4, there you go, from 0 to 1. Okay. So now what I'm going to do here, y'all, I'm going to take my 2 pi, we're going to plug in a 1, so that's going to be a 1/4, minus, we're going to plug in a 0, that's going to be 0 over 4. Okay. So my 0 over 4 is just going to go away, isn't it? So I'm left with 2 pi over 4, which is just pi over 2. And then again, y'all, if you want to do this on your calculator, all you're going to do here, y'all, is go, let me clear this here. You're going to go pi divided by 2. I'm going to hit enter, and I'm coming up with 1.5708. Now, y'all, one thing I want to emphasize in these problems is the picture is important. The picture is important because it helps you find your limits of integration. How accurate does your picture need to be? Not super accurate. You know what I mean? It's not. It doesn't have to be all that accurate. And the other thing I want to mention is I want you to, you know, when I'm doing this method of the shells, and maybe I should call it like the stick of gum method, because I think that kind of, you know, it gives me a visualization. You know what I mean? I don't know if it does for you guys, but it does for me. It gives me like a visualization, right? What I think about is when I'm drawing that little shell, right, or I'm doing that kind of action there, I can kind of see what my x and my f of x are, and, you know, I can kind of get a better idea of what's happening. But when I do the third problem, y'all, I'm gonna show you a method on the third problem. I'm still following the same formula, okay? But I'm gonna be less worried about how accurate my picture is, and I'm going to be a little more focused on using my formula. The reason I'm showing you guys like in this much detail is because I want you to get a visualization of what's happening, right? Think about that piece of gum, right? We rotated this little stick. We ended up with kind of like a piece of gum that was real thin. And then we can find the volume of that. And because we're integrating over, from 0 to 1, we're doing this, so many times because that thickness is so small, but we're adding them all up, we're finding our volume, right? So look, I'm going to come back over here, y'all. And what I'm going to do for this problem is I'm going to just copy and paste the formula. And I want you to see if we can follow along with that. And again, I'm not saying that, by me drawing the picture and trying to be as accurate as I can is not helpful. I think it's really helpful. But I don't want you to get too bogged down with it. Okay. So let me do this. Okay. Okay, so guys, look what I have here. This is my last problem out of 6.3, and it says we're going to find the volume of a solid obtained by rotating the region bounded by the curve y equals 2x to the fifth, the line y equals 0, and the line x equals 3 about the y-axis. Okay, so let's see if we can't figure this thing out. First thing I'm going to do, y'all, I'm going to draw my picture. And y'all, just to give you a heads up, let me clear this out here. Clear that here. If you want to know what 2x to the fifth looks like, by all means, graph it. You know what I mean? So, okay, so take a look. There we go. There's my 2x to the fifth. I can kind of see what's happening, right? 2x to the fifth. I can kind of see what the graph looks like. If I want to, you guys, I can, make my window a little bit smaller. So let me go, say, from -4 to 4. Let me my y min be -1. Let me let my y max be, oh, I don't know. I'll leave it at 10. Okay, let me graph this now. Okay, so look, there's a little bit more of an accurate picture of what I'm getting, right? Tell me, John. Okay, so look, so everybody good with the picture? And again, all I did, y'all, is graph it, did some settings on my window to kind of get a picture of going on here. Okay, so look, my graph starts to do something like that. Okay, there's the y equals 2x to the fifth. Okay, now we're going to bound that by y equals 0, which is this line right here. And we're going to bind that also by x equals 3, which is this part right here. So again, look at the region that I'm looking at. Everybody agree that's the region that I'm looking at right there, that region in the green? Okay, and again, we're going to rotate this, y'all, about the y-axis, right? So all that means, you guys, is that the other piece of my graph is going to look something like that. And when I'm rotating it, again, that's kind of what I'm getting. Okay. Yeah, we're not looking at the bottom parts at all, because we're just looking at what I have either in the blue or the green, right? We're just looking at this part right here. You know why? Because it's bounded by the line y equals 0. Does that make sense? Good, good, good. So excellent. Good point. Good point. Guys, even when I'm doing these problems, I have to really like take a look at, okay, what part am I looking at, right? Okay, so look, let me ask you a question. Just by looking at the picture, and since we are rotating it about this line right here, does anybody know what are the limits of integration from this point to this point? 0 to 3, okay? So guys, I'm going to show you something. I told y'all that we can use, in this problem, y'all, I'm going to go with a little bit more of a straightforward approach. Okay, I'm going to use my formula. So look what it says. The volume is 2 pi, okay? We said from 0 to 3, okay? Look what the first part of the formula says. First part of the formula says x. Let me write it. Second part of the formula says f of x. Guys, my f of x in this case, everybody agree is 2x to the fifth times my dx. Okay. 0 to 3. X times 2x to the fifth, everybody agree that's a 2x to the sixth power? Because I got to add my exponents together. So far, I'm okay. I'm just, when I multiply these two together, don't I get 2x to the sixth? Am I good so far? Not just, am I doing okay? Yeah. Okay, so look, y'all, let's go ahead and keep working here. Here's my 2 pi. Okay, we're going to start finding some antiderivatives. Anybody know what is the antiderivative of 2x to the sixth? 2x to the seventh over 7. Okay, and y'all, again, we're evaluating that from 0 to 3. Okay. Excuse me. Okay, so guys, one thing I can do in doing this problem, since I do have this constant of 2/7, I can multiply that by the 2 pi. So 2 pi times 2 would give me a 4 pi over 7. And then I can say, look, I'm going to integrate this or evaluate this from 0 to 3. Does that make sense? Okay. So y'all, when we're going to plug these numbers in, the only number we're really plugging in is 3, because when you plug in 0, we know it's going to go away, right? So we have 4 pi over 7 times 3 to the 7th. Okay, when you plug in 0, again, that's going to go away. And 3 to the 7th is probably a pretty big number. Boom. 2187 times 4. Okay, so if you're going to write an exact answer here, y'all, I would have 8748 pi all over 7. That would be an exact answer, and then you can obviously find the approximation by multiplying it by pi and dividing it by 7, and I'm coming up with like 3926.0932 or whatever, right? And that's all you're doing. So guys, again, the main reason why in the first 2 problems I was kind of walking you through the process was to get a visualization of what's going on, right? And then for you to understand that really what I'm finding here, guys, is I'm just finding the volume of a box. What I want to emphasize, though, is that if it's difficult to get that visualization, I want you to notice, though, when we did the third problem, I mean, I drew my picture, right? I drew the graph that I was looking at. And I drew the graph, and you notice, I never drew my little rectangle that I started rotating. No, I didn't draw that here. But let me ask you a question. By using this formula, and again, the first thing we said was, okay, what are my limits of integration? We were able to find those limits of integration, right? And then plugging this part in directly here, was it a little bit more straightforward? Yeah? Okay, so again, you have a couple of options, right? The main reason I was going through that first process was to kind of walk you through so you can kind of see what was going on. If it's difficult for you to do that process, guys, then you can definitely just apply the formula, right? Apply that method, and it's going to work really well. It's going to work for you every time. Guys, in 6.3, again, we were using this idea of the shell method, but we were rotating in about which axis? Right now? The y-axis, right? So guys, with the disk method, that's when we're rotating about the x-axis or horizontal line. That's when we use like the disk method, right? When we're going with the y-axis, that's when we go with like the shell method. Does that make more sense? Okay. So guys, that is 6.2 and 6.3. Not very long sections, right? We got through both of them. Again, for homework, you guys, you have from 6.2, I want to say there was a total of 5 questions. We had already done 3. I'm not saying that we had already done those problems, but we had already done 3 of the problems. So we finished up the other 2 today. For 6.3, you only got 3 questions. Guys, next week on Monday, we're going to do 6.4. That's the last section I'm going to teach you. Again, only 3 questions. I'm going to tell you that the way we're going to do those problems, you guys, it's going to be calculator way. Okay? It's going to be straight plug and chug calculator type code. Okay, and I'll explain why it's going to be calculator work, but that's what it's going to be. And so we'll do that on Monday. Again, 3 questions, not a lot. Guys, the other thing I really wanted to emphasize is that because the semester is winding down so quickly already, next Wednesday, a week from today, that's going to be one of the days that we're going to use to review, right? And then the following Monday. So again, let me do it this way because I want to make sure that everybody's really good with what it is we got to do. So let's see. This is Monday. This is Wednesday. So next week, Monday should be the what? The second? Yeah. Okay. So I'm going to go like this: May 2nd, May 4th, May 9th, the 11th. That's one. Okay. So this day right here, you guys, we're just going to go 6.4. We're going to review. We're going to review. No class this day. Okay, and this is Thursday. The final is due at 8 p.m. Okay, so the final will open here. And not, guys, I really want to emphasize 8 o'clock. Okay, not midnight, 8 o'clock. The reason being, guys, I have to turn in my grades the next day. Okay, so that's why it's 8 o'clock because I got to have time to, compile everything and put all that kind of stuff together. Okay, so again, Monday, guys, one section, 6.4. Next Wednesday, review. Next Monday or the following Monday, review. And then that'll be the last day that we see each other for this semester, guys. So, don't cry. I know. It'll be sad for me too. Guys, I don't want to get too sappy, and I'm not going to, but I want to say, but I want to say, guys, thank you guys for making my first experience teaching calculus in a long time, because the last time I taught it was 2008. Thank you guys for making this such a good experience. It really was great. I really enjoyed having you guys in class. I think we did good as a group. I like the fact that we had, so much communication on Pronto. And guys, I don't know what your experiences are in your other classes, if you guys use Pronto a lot, but I like using it because I think it's helpful. I think it's helpful. I like the fact that if somebody asks a question and I don't get a chance to answer it, because like sometimes, so guys, like once my office hours are over, they're over, right? And I don't have my prompt on my phone, I have it on my iPad. And once it's over, I do this on my iPad and it goes into the other room, you know what I mean? So like right now, because I still have this thing here open, look, I got 11 messages on Pronto, right? I haven't had a chance to check them yet. So I'm going to check them, right? I'll respond. But, sometimes if you message me on Saturday or Sunday or whatever happens to be, or you message me after class is over or after office hours is over, and I'll get back to you and you put it in the group chat, a lot of times we're like, hey, try doing this or try doing that, right? I think that really helps a lot, guys. So if you have the experience in your other classes and your teacher uses it, use it. I think it can be really helpful. And I understand, like, I don't have this issue with you guys, but like with some of my other classes, people are sending messages 3 or 4 in the morning. So if you do get and I don't know if y'all have you.
Issue with English Katuwa. What's Katuwa? They're like assignments that come in. It's a paper. Like, so guys, how you doing on your essay? And it's like 10:30, and like I turned it in 2 days.
Yeah.
Like,
So I don't know if you guys have had that experience. So like I was one of the classes that I have on Tuesday and Thursday night, right? I have students that are closer to my age, right? I'm 48, so I have people in there that are 30s and 40s and whatnot. And like one guy said, I took it off there because it was like 2 or 3 in the morning, my phone's going off. And I said, well, I can understand, that gets frustrating. So, in your Blackboard class, there should be a link to Pronto, so you can always check it there too. I said, the other thing is turn off your notifications. You know what I mean? Just turn off your notifications so that you're not getting dings at 3 or 4 in the morning. And I understand there's a lot of people who, I'm a night guy, right? I'm a night guy, guys. So a lot of times, especially like in the summer, I'm up to like 3 or 4 or 5 in the morning. And if I'm teaching a class, I'm doing stuff at that time. Now again, I'm waking up like at 11 or noon. You know what I mean? Because I'm like summertime. You know what I mean? Like I'm trying to chill as much as I can. But what I'm saying is, if you get that experience, turn off the notifications or whatever. But I think Pronto works really well. And I just really want to say thank you guys again for making my experience going well. I hope you guys had a good experience too. And if you end up taking Cal 2, which I know a lot of you guys probably are, good luck. And anything I can do to help you guys, let me know. So you can always still message me, next semester over Pronto saying, sir, I'm taking Cal 2 with so and so, and then can you help me with this problem? And I'll do my best to do what I can. Okay, so I get that all the time.
Cal 2, come on.
Yeah. And I don't even know if we're offering a section of Cal 2 here. Are we offering a section? Is there?
Accessible or is it's only online?
But in the fall too, like let me you know what? Let me do this. Let me stop recording.